A shadow moves at the edge of your vision. Your body reacts before your mind even catches up. Your shoulders tense. Your breath catches. You haven't even turned your head yet. And already you're bracing. You didn't decide to do that. Something older than thought made that choice for you. This happens dozens of times a day. A car horn. A sudden movement. A loud voice behind you. Your body flinches first and asks questions later. Why does this happen? And why can't you stop it? The answer starts deep inside your skull, in a small almond-shaped structure called the amygdala. Neuroscientist Joseph LeDoux spent decades studying this structure and found something strange. Threat signals don't travel to your amygdala through your thinking brain first. They take a shortcut. LeDoux called it the low road. Sensory information splits into two paths the moment it enters your brain. One path goes to the cortex, where you consciously recognize what you're looking at. The other path goes straight to the amygdala, skipping conscious thought entirely. The low road is faster, much faster. It can trigger a full-body response before your visual cortex has even finished processing the image. This means you can flinch at a shape in the grass before you know it's a stick and not a snake. Your body reacts to the possibility of danger, not the confirmed fact of it. That gap between reacting and knowing feels like an error. It isn't. For most of human history, hesitation was expensive. A crouching predator in tall grass doesn't wait for you to be sure. Neither does a rival tribe member with a weapon. The humans who survived long enough to have descendants were not always the ones who correctly identified threats. They were the ones who reacted fastest to the possibility of one. Anthropologist Sarah Hrdy has written extensively about the selective pressures early humans faced from both predators and other humans. Constant low-level vigilance wasn't paranoia. It was the baseline cost of staying alive in an environment where the difference between a false alarm and a real one could be measured in seconds. Your amygdala doesn't run on logic. It runs on pattern matching, built from millions of years of ancestors who lived or died by how quickly they responded to sudden shapes, sudden sounds, sudden movement. That's why you can watch a horror movie and feel your pulse spike at a jump scare you saw coming. You knew, intellectually, that nothing was actually going to hurt you. Your amygdala didn't get the memo. It doesn't care what movie you're watching. It only cares about the pattern, sudden motion, unexpected sound, possible threat. Psychologist Joseph J. Campos studied how this system develops in infants using something called the visual cliff experiment. Babies as young as crawling age would hesitate or refuse to cross a surface that looked like a sudden drop-off, even when a clear glass panel made it perfectly safe. Nobody taught them to be afraid of heights. The wariness was already built in, waiting to be activated. Here's the strange part. Your fast-reacting brain and your slow-thinking brain are almost always in disagreement. The amygdala says danger. The cortex, arriving a half-second later, says false alarm. It was just a shadow. But by then, your heart rate has already jumped. Your palms are already damp. You live your entire life a half-second behind your own instincts. Modern life didn't remove this system. It just changed what triggers it. A notification sound, a boss's name on your phone screen, an unexpected knock at the door. None of these are threats to your survival. Your amygdala doesn't know the difference. It fires anyway. The same ancient circuit responding to an email as it once responded to a predator in the brush. This is why chronic notifications, constant background noise, and digital interruptions leave people feeling exhausted in a way that seems disproportionate to the actual events. Your body is running the same threat response system it evolved for a world of physical danger. Except now it fires dozens of times an hour for things that were never dangerous at all. Some researchers, including LeDoux himself, have suggested that understanding this low road is key to treating anxiety disorders. If a system is built to react before you can think, you cannot simply reason your way out of a flinch. You can only learn to recognize it for what it is: an ancient alarm, still doing its job long after the original danger disappeared. So the next time you flinch at a shadow, a sound, a sudden movement that turns out to be nothing, remember what actually happened? Your body didn't malfunction. It did exactly what kept your ancestors alive for hundreds of thousands of years. You didn't overreact. You just haven't caught up to your own reflexes yet.